let's get started then. So thanks to everybody for being there. So I am Vincent Hourdin. I am one of the developers of Siril. We are currently 4 developers. I was the first one to restart the project after it had been abandoned in 2005, and I restarted it in 2012. So it's been 9 years for me in this adventure already. I am a computer scientist, or more precisely now a computer engineer, as I work for a company. So what is Siril? Just for if anybody doesn't know already, so Siril is a free software, which means that it's free of charge and that the source code is available to anybody and it can be improved by anybody. So anybody can participate to the software, either for documentation, for programming, for tutorials, for anything. Translation too. It's translated in 15 languages, I think, but we develop it in English, so you don't need that. In which case do you want to use Siril? It's mainly used for deep sky images. In some cases, it can be used for planetary images, but not for planetary, high-resolution planetary images, let's say, because Siril only supports one alignment point for the registration of images, while when you do high-resolution planetary images, you need to account for the atmospheric turbulence, and you need to register some parts of the images with each other. So it's called the multi-point registration, and Siril currently doesn't do that. But if you have full moon images, for example, or very small planets to align, it can still work because multi-point planetary alignment is not required. But usually we use it for deep sky images. Recently, the CMOS cameras have improved so much that we can do also the short exposure deep sky images. It's like 1 second or even below 1 second sometimes exposures that are combined together. So it's like tens of thousands of images to combine to create a very high resolution image. The goal of shortening the exposure time is to freeze somehow or to improve the resolution by having less effect of the atmospheric turbulence. So it's not completely freezing the turbulence, but lowering the effects of the turbulence. And a lot of people use Siril for that because it's very capable of handling big files. And it's also quite fast to process these big data sets. So yeah, for deep sky images, Siril is a good free alternative, I think. And to conclude with this small introduction, something that you will need probably someday is where to get help on Siril. So we have a new website. It's relatively new. It's less than 1 year old, in which we have a lot of resources. At the top, you have all the links that you might need, like the tutorials, the frequently asked questions, the forum links too. We have an English forum. And yeah, many links in the tutorials. As you can see, we have not a lot, but they cover a lot of the basic things. And the one that I will be like using, or what I will be showing you tonight, is part of this tutorial for the whole image processing using scripts. Except I will not cover the first part that gives you the stacked image, but only the end of the tutorial, that is about the processing of the result. But it's all described in a lot of details. So I even took the images that are given as a sample in this tutorial to show you tonight. So if you want to review what we have been talking about tonight or this evening, you can look at this website, siril.org, and you'll find the tutorial and everything will be explained. I may give you more details by talking you through it, but it's still very well detailed, and every button that you need to click is annotated like that. So let's go into our processing. So just to explain a little bit how we get to the processed image, I wanted to explain a little how we get there, and I will not show it because it's explained in the tutorial, but I will just make a brief explanation of why we do that and how we do that. So the process of what we will call pre-processing the images to get the stacked image has a few goals. One being that we want to take many exposures of the target object, because the single exposures have many flaws that we want to remove. There are many contributing signal, how to say that, there are, yeah, the image contains some noise and contains some signal that we don't want, and that the pre-processing step will aim to remove. So we do that by taking a lot of images and also some calibration files like the offsets, the dark images. So the offsets remove the readout noise. The dark images remove the current, the thermal current, which is proportional to the temperature and the exposure, and also the flat field images, whose goal is to get a better uniform response throughout the image, because on the sides often we have vignetting due to the optics, and we also have different response from each pixel of the camera or photo sites of the camera. And so we might not get very uniform images. And so once we have taken all these different images, single images, they can be processed quite easily. With Siril, it's basically automatic. You just have to place the, I will show you, you just have to place the corresponding images in some directories like that. So here I have the light images. So the lights are the images of the target that you want to make a picture of. The darks, the biases, so it's offsets actually, and the flats are all in this directory. And then I just start Siril with, let me start it. I start Siril, I go in, I tell Siril that I want to process something from this directory. So this will appear here. So that's my directory on top there. If because I just put it this afternoon, but otherwise you have to click on this home button and select the current working directory. This is very important because otherwise you will be processing images that are not the ones you think. So make sure you select the correct directory. And then you just have to go in the scripts, and the scripts are automatized processings. And for this image that we will use this evening, I use the OSC preprocessing script. So just clicking on that will run the script for a few minutes in our case, because it's a very small data set. And I will get a result.fit file in my directory. And this is what I got here. Result.fits. So maybe I configured it for the fits extension instead of fit, but by default it's fit, sorry. So that's the basics. So it can also be done manually using all the tools that are in the different tabs of Siril. So there is the pre-processing step, the registration step, the plot to visualize the quality of images throughout the session of acquisition, for example, and the stacking phase. This can all be done by hand if you prefer, and if you want to fine-tune what the script automatically does, but it's not required. You can just use the script, and it will give you this image that I will reopen. Okay, so it's all black. That's normal, because that's actually one of the most important things to understand. It's the linearity of the images. What we call linearity of the images is the way we display an image based on the pixel values. When in Siril we have a few tools to change the display, that are at the bottom of the window here. And you see here there is a box that says linear. We can change that to a few other values. The most useful being auto stretch, and I will activate it now, and you will see. So it's a color image. So we have 3 channels: the red, the green, and the blue. And yes, OSC in the script means on sensor camera. No, sorry, on sensor color, or it also means one-shot color. So it depends where you read it, but it's basically the same. It's cameras that have a Bayer matrix or another matrix. Like for the Fujifilm cameras, they have a stranger, let's say, filter matrix on top of the sensor. So it means that with one shot, one exposure, you get information from 3 channels in general. So you don't have to, for example, if you have a monochrome camera, you need filters, and you will take 3 exposures to get the same color results. Here you have one shot color camera, so that's why I use the OSC preprocessing. So my result is a color image. I can see the red, green, and blue channels. And so what I was saying was that the linearity of images is something very important, because when we open it at first, we see that our image is very dark. We have cursor that we can change, but it remains quite dark. And in fact, you can imagine that as what you would see if you were looking at this portion of the sky through an eyepiece with your eyes. The stars are much brighter than the nebulas or the galaxies or other faint objects of the sky. And that's so the eye is not really linear, but it's closer to what we should see with the eye. And for processing purpose, or for to check the quality of images, and when we are trying to process the image, we'd like to see better what we are doing, and to see better what kind of signal we have in the image. So we will just change the way the image will be rendered on screen. And this is what this box and the cursors also do. What I mean by changing the way the image is rendered is that the pixel values of the image don't change. They are still like, if we take a range of 0 to 1 for the dark and light, the stars will be very close to 1, and the nebula will be very close to 0. But so we don't change the pixel values of the image on the disk for now. But on screen, we would like to see the darker side of the image more bright. And that's what we do with the visualization cursors or the visualization modes, like the auto stretch here. So I insist that the image pixel values are not changed at this point. It's just the way the image is rendered. And by the way, if you have questions, don't hesitate to interrupt me if something is not clear. I can stop and take questions like that. So we can start processing the image now. All the tools that we will use are in the image processing menu here. So we have, I will not do the list because we will see it in the various steps that we will take. So I've written 8 steps on the processing functions list. These are the same as those you will find in the tutorial on the website. And we start by removing the gradient that can be seen on the background. So it's not always the case, but it's generally the case. When you have, for example, the moon on one side of the sky and you are taking a picture, you will see a gradient with the light being, the background sky being lighter on the side of the moon, for example, or brighter on the side of the cities too. So this can, the first step can be to remove this gradient. So here we can see it's probably lighter on the left of the image and darker on the right of the image. It's not very easy to see, but in any case, you will probably need to use that. So I will show you how to run it. So we have a background extraction tool here. It's quite simple. It's almost automatic. You have to click generate. What it will do is generate a grid of samples on the image where it will measure the average values inside the boxes. They look quite small, but it's a very big image. So if I zoom in, you will see that there are at least 20 pixels, I think. Yeah, it's no, it's not what this means, but it's a fairly large square. And that's enough, even if there are some stars in the boxes. It's not very important because Siril will reject the pixels that are above the background value or that are at least too far from the average of the background value of the image. So it's not a very important thing to ignore the boxes that have a star in it. But the boxes that have a nebula in it, which are not part of the background, should be removed. And so, for example, we see here that this one and a few on the borders of the nebula are inside the nebula. So we might want to increase the tolerance. I think, no, I have to click generate. No, so sorry, it was decrease the tolerance then. And it will remove the points that are too far from the average background. So like that maybe would be good. You can also click on, oh, yeah, you have to go, I think, on monochrome view, and maybe you can add some boxes if you like by just clicking on the image, and you can remove one I think by right clicking on the image. Yeah, that's it. If you like, if the automatic process didn't place the boxes well enough, that can be done too. So once you've placed your boxes the way you like, you just click on apply. I will return first to the RGB view to show you the what happens when we do that. So it will compute a polynomial background from the boxes for the samples of the boxes, and it will subtract this from the image. So now we have a much more uniform image. It's still not looking very good because of the green, but it's normal at this stage. We don't have, yeah, something that I haven't told is that the when you have, even when you have a one-shot color camera, the resulting color of the preprocessing is always not correct, is always incorrect. Don't expect a color that looks real in your stacked image, because the camera sensor has different responses for the different colors, and the different processes that that the image goes through may not preserve in all cases the colors of the image, and the white balance of the camera is meaningless because in general it's not suited to the sky. And also we don't take it into account when we convert from the raw images if you have a DSLR camera, for example. So we just process the pixel values as they come and not really taking into account white balance before this processing step. And that's actually the second step of what we'll do now. So now that I have removed the background gradient, we can see that the image is more uniform. The background is more uniform. And so we can close, and we're happy with that. So we can close this tool and go to the next. So the boxes disappear. Now we'd like to have a less green image, and we can proceed with the color calibration. So there are two ways of doing that. Either you can do it manually by selecting an area of the image that you would say is black, or is supposed to be the background, let's say, which is supposed to be black. And in that case, that's a manual color calibration. So if you go in the color calibration submenu, you have the normal one, which is the manual one. And the second one is the photometric color calibration. This one is more automatic, and it's so I will show you the manual one first, in case you cannot use the second one, and I will tell you later when you cannot use the second one. So here I've made a selection on the image, and where I thought it was supposed to be black. In this tool, I can use this selection. So I clicked here, and now I will go back to the RGB view to show the effect. Now I click on background naturalization. It will make the background gray, or more less tinted at least. Okay, so it's not bad actually. It's quite realistic, but it may not be completely well white balanced. There is also in this window a way to change the white balance, either manually with cursors, which I don't recommend because it's very hard to judge. And there is another way, which it's basically like what I've done for the black area, or the background naturalization. The goal of this step is to align the histogram of all the channels, the 3 channels colors, to the same value. So probably it takes the green, and if the red is higher, it will move it lower, and the same for the blue. And if it's lower, it will bring it higher. And we can also do that for the white balance. If we have an area on the image that is supposed to be white, which is not very frequent for astronomical images, we can draw a selection. So let's say this is supposed to be white, except it's supposed to be pink probably, but we can use this selection and apply, and it will change the white balance of the image. So now the blue is more blue, the pink is less pink, but we have done our color calibration manually. So this requires having a patch of dark in the image. So when you have a full-size nebula, you cannot do that. And also having a part of the image that is supposed to be white, which is not very frequent. But at least you can do the first part with the black naturalization. It's already a good thing to do. So now I will show you the automatic way. So I will go back. And yeah, so that was the image we had after the background extraction. So I see there are messages in the chat. I will take a look. Yes. Oh, yeah. So something I have not said for the background extraction. So I've shown you how to apply it on the stacked image. And the problem with that is that if you have a long session of acquisition, or if you have even several sessions across several nights of acquisition, you may have a gradient caused by the cities, the moon, and whatever, that rotates a lot during these sessions. And so you will end up with a stacked image that has a very complex background gradient to remove. And the tool cannot really handle a very, very complex gradient. So an alternative to that is to remove the gradient on each sub-exposures. This is an option of the tool, actually. I should have shown you. Background extraction. You have apply to sequence. So that can be done manually if you are using manual preprocessing, but that can also be done in the scripts. I think I've seen someone post one new script that is not provided with Siril, I mean, on the website that contains this option, but otherwise it's quite simple to add to an existing script. If you want later, I can show you how to do that, but because now it will take like 5 minutes, but so it's possible to process. So if you do that, you will only need a 1 degree polynomial to remove the background, because in general on sub-exposure, it's very simple gradient that goes from one direction to from one side of the image to the other, and there is no waves like what you can have in the stacked image. So it's much simple to remove, and it means that in the stacked image you're not supposed to have a gradient if you use this technique. So to answer the question, yes, you could call it several times, but in general, if it fails the first time, it's unlikely that it will get some good results the subsequent times.
Thanks, Winston.
So let's go to the automatic color calibration then. So this one will use photometric information from the stars in the image. So it means that you need to have a good number of images of stars in the image. So this one is a very large field of M8 and M20, so the Trifid and the Lagoon Nebula, I think. And so we clearly have enough stars, but in some cases when you have a narrow field of view, maybe it's not possible to use it, or maybe the database we will be querying will not find the objects that you have imaged or that you are trying to get in the image. So I will show you how to use that. So here I know I have M8, Messier 8 in the image. In general, we choose the Simbad version. So you have to click on one of the results. This will get the right ascension and declination from the web service. So it's calling Aladdin, I think. I don't remember actually. But anyway, we are querying a web service from the name of the object to get the coordinates of the image, at least a part. A part of the image should contain the coordinates. And we need to get metadata from the image, or we at least we need to get the focal distance as close as possible and the pixel size as close as possible. If you don't know it, you can find it on the internet. For astronomical camera, it's quite easy to find. For DSLRs, there is a website that lists the different pixel sizes, and you will find the link on the website tutorial. So here it was already stored in the image. And one of the, so what will happen now is that from these coordinates and from the size of the, well, it's basically the resolution of the image. So we know the pixel size and we know the number of pixels and we know the focal length. So from that, we know the field of view in degrees or arc minutes of the image. And centered on these coordinates, there will be a query on the web server that will ask for all the stars in this area, limited to some magnitude, of course. And then we will detect the stars in Siril that are in the image, and we will try to correlate the position of the stars that are given by the web service and those found by Siril. And from that, we will know where is the center of the image exactly. So it's a plate solving. And also, we will know in the image which star is which in the sky. And so for each star, we will also get from the web service an color profile, let's say. It's photometric information as like how much green it radiates compared to blue and to red. And we will use that to make an average of the deviations that we need to apply on the 3 channels of the image to have an automatic color calibration. So I will show you. No, before there are 2 options here that you may find useful. The first is flip image if needed. So in some cases, because of the mirrors and because of the way the images are stored in the FITS format, the image can be upside down, or of course, if you have turned your camera, it will be upside down too, or on the side maybe. So since we are doing a plate solving here, we can automatically return the image if it's not in the correct orientation, if you check this option. The second option is down sample image. If you have a big image, like if you have a very big sensor and if you have activated the upscaling of the images for the processing, for the pre-processing, it will take a lot of time to find the stars in the image, or a lot. It can be like 10 seconds. But if you want to improve the speed of this calibration, you may downsample the image. It will be easier to find a match with the sky stars. So now let's go. Click on OK. Yeah, I should have shown you the console actually. So I will do that. It's querying. Okay. And now on the so the console tab is quite useful because it's here that you can see the different error messages if there are any of Siril, but also what happens with some of the tools. And in that case, we have here the color calibration factors. So we see that one of the channel was basically divided by 1.8 and the other by 1.36. And oh no, sorry, that was the one that I made manually. So it was still querying the web service. So it found the center of the image and the actual resolution and the focal length that matches the sky view that is in the image. So we have the precise focal length of 398 millimeters, 0.52. It's very precise. We have the it's based on the pixel size, of course. So if you change the pixel size, you will have a different focal length. So it's important to have the correct one. You have the exact center of the field of view. Sorry, it's here. You have the size of the field of view. So it's quite large with 3 degrees by 2 degrees. So it's a very large image. It has detected that the image was rotated. So yeah, it's 108 degrees off. So it automatically, flipped it or rotated it. No, actually it didn't rotate it, but it flipped it because it was upside down, sorry. And it found 461 stars. Some were excluded from the computation, and then we have our factors for the color calibration. So it's not the same as the ones we had here, but maybe it's because it's not the same reference channel. And that's it. We have our photometrically calibrated colors in the image. So that's what it should look like given your image was taken with RGB filters that match the ones that are used on the online database of stars. For some cameras, in particular those that filter out the H alpha of the part of the spectrum, so the longer wavelengths of the red, so closer to infrared. There may be a slight difference with the actual color, but in general it works pretty well and it can be considered as quite accurate. So remember that this is an auto stretch, so it's a stretched histogram for the image. The actual image still looks very dark, and actually if I put the cursors to the maximum, it's still very, very dark, but that's something that is closer to the naked eye or to the actual radiance of the objects in the image. Okay, so now the next step is optional, and it's the deconvolution. So if you have an image in which the stars are not very round, if you have optical defects, an optical effect that makes the stars not look very good in the image, or if your mount doesn't follow the stars very well, the Earth's rotation very well, and you end up with stars that are a little elongated, there is the deconvolution operation that can be applied. So here it may not be very useful, but I will still show you. I will zoom in so we can better see the shape of the stars. So it's quite good. And even on the side, probably, yeah, we can see on the side it's not as good because there is a chromatic aberration, with the red being more distorted than the blue. But the tool will only work on the complete image for now. So it will not correct the roundness of the stars on the corners or the edges, but for the complete image, for the whole image. So if we zoom in a bit and see what the stars look like, and we open this tool, so it's called deconvolution. So we have a few cursors, and we see that with the default settings, we already have a big effect on what the stars look like. So if I disable the preview, you will see the color images go back to what it was before. So the stars are bigger originally, but the deconvolution, when I activate it, will make some artifacts on the stars. Most of these artifacts are due to the chromatic aberration. You can see that the stars get bluer on the top and redder on the bottom. So it must be used very, very carefully, this tool, because it will give you some artifacts. And so you will also, you will not be able also to consider that the image is pristine and the pixel values are pristine. If you want to do photometric measurements, for example, it will not work anymore because you will change the values of the magnitudes of the stars even will change, and so it's just for good-looking purposes, let's say. So you may adjust the cursor to have less effects, and once you have found a setting that suits you, you can apply that. Let's say here it's better than it was before. And we have our deconvoluted image, in which the stars should be sharper and rounder. So it's not a mandatory step, but it can be done at this step. All the operations I'm telling you about should be done in an order that is similar to what I'm doing, and that is also written in the tutorial, because some of the operations don't work after histogram transformation, for example, or the opposite actually. And one extra thing that I wanted to tell you is that on every step, we modify the image that is loaded, but not the image that is on the disk. So if you don't want to lose your current processing, you may save it either by clicking save here, which will overwrite the image you had. So it's maybe not a good idea. Or using this button here, it will save as, so it will allow you to change the name of the file being saved. Something else I had to tell you about what happened in the photometric color calibration is that since Siril made plate solving and that the image coordinates are known, we have this new depends when you knew Siril first, but it's from this year. This tool will show you from a database that we have in Siril the major objects that are in your image. So here we see the big one is M8, and we have M20, the Trifid nebula, but we also have open clusters, we have dark clouds, we have a lot of things, even stars. The big stars are also labeled in the image. Here we have a globular
Sorry,
cluster.
Vincent, I didn't see how you got to that.
Yes, I will show you again.
Yeah.
So this is this button at the bottom.
Okay, yeah.
And it only works if you have done a plate solving before.
Okay.
So
right.
the plate solving can also be done manually. I mean, outside the context of the color calibration if you need. And if you need that, it's because if you have a monochrome image, for example, you won't be able to do that. And you can do that from image information. Oh, sorry. Yes, okay, like that. Actually, even better. So I start again. In this burger menu, as we call it, with the 3 slices, you have image information, image plate solver. And so that's the same menu that you saw in the photometric color calibration. And you can do that if you don't have a color image, for example, and it will still show you this kind of information on your images. If you have a large enough field that contains well-known objects, because we don't. This is the embedded database of Siril. It's not a query to the web service this time, and we will not display like this the very faint objects or if you are shooting for a variable star, for example, it will probably not show in this view. But the Messier object, most of the NGCs that are bright enough will show in this. And also, if really you need to know what's in your image, you can. So I think I need to go on the monochrome layer to do that. But If I do that, oh, it's a bit large. So if I want to know what this star is, now I can go in the PSF menu, and if I click on more details, it will bring me to the page of the star, actually, which is quite neat. It's it's a good way to know what's in your image if you are lost, or if you, but actually if you're lost, it will not work because you will not be able to plate solve it if you don't know where you are pointing. But yeah, so that's an example of what we use for the photometric color calibration, the RVB lines here, or G maybe, I'm not sure exactly which ones, but these are the magnitudes for each filter. So that's what we use for each star of the image to realign the different colors and make it look correct. Okay, let's go back. So getting the information on the star was selecting a star on the monochrome layers, right-clicking and getting the PSF menu, and then you have the more details button here that will open the web browser with the guest coordinates, which in general will find the star. You also have, of course, the FWHM information, the background value, the amplitude of the Gaussian, and so on. Okay, let's go back to our image. And let's disable this to see it better. What's next? So we've done the deconvolution. So now we want to make the image look bright like that, but while still being in linear mode. Why? Because when you will export this image, when you have done all the processing you need and you want to save it as JPEG or PNG image to post it on a forum, for example, or to keep it in your library, what will be exported is the linear view. It's the actual values of the pixels of the image that will be converted to JPEG or PNG and so on. So if you want to have your image looking like that, oh, sorry, wrong line. If you want to have it looking similar to that, or maybe change, and also maybe it doesn't suit you because for me, for example, I find the background too bright here. So anyway, you will have to modify the histogram of the image. So that means modifying the values of the pixels of the image to make the dark tones brighter. Basically, it's in general what we want to do. In planetary images, it's not like that, but in deep sky images, it's like that. So now to complete this task, we will revert to linear and make sure that our cursors are the minimum and maximum so that we see the whole range of pixel values. So we can still see the stars because they are very bright. So if we just amplify the image without taking care of the overflows, the stars will just get saturated everywhere on the image. So we just really want to brighten the dark side of the image, let's say. We have a few tools to do that, mainly the AsinH, so it's arcsinus hyperbolic. I'm not sure the English term, but and it's a transformation that improves the dark values, that brightens the dark values. And the second one is the actual histogram transformation, where you use the curves, like in Photoshop, for example, to change the way the image looks. The tutorial says shows that we can use the two of them in combination. So we will start with this one. So it's almost like so it's actually the same as doing that, setting the mode to AsinH, except here it just changes the way the image is rendered. And in this tool, it will change the pixel values of the image in the same way, but of the stored image and or actually the loaded image. And so since we want to see what we are doing, we will go back to the linear mode and start changing the two cursors, which are the same as, no, sorry, it's maybe not the same as the two that you have below here, but anyway, the effect is basically the same. The first one will brighten the image, and the second one will change the 0 value of the image. So if you increase it, the background will get darker as a higher pixel value is taken as the background. So you can improve your image like that. Apparently, it preserves the color better than doing the histogram transformation with the other tool completely. I'm not sure if there is an actual difference, but it's a smoother way to do it first, at least, and maybe an easier one too, because the other has more tweaks and more controls, and this one only has two. And so when you are happy with how bright the nebulas are looking, you can adjust the background. Yeah, maybe it was not so bad actually. Let's say I like my image like that. So I click apply, and now the pixel values of the image have been modified. It's still not saved because I didn't click on save, but let's say I want to save it like result after ACNH. And now I have my intermediate image if I want to go back to the processing to restart some of the next steps. Then we can use the second histogram transformation tool. So this is more like what you will find in usual image processing tools. What we do in general is just move the central cursor left. So this will, as you see, increase the brightness of the dark values of the image. So the three curves we see, actually the green and blue are overlapping, but we can clearly see the red because the image has more red because of the nebula in it. The peak is the background, the sky. It's not the nebula, but the nebula is very close to the values of the background pixels. But so it's clearly not the stars. That's what I mean, at least, because the stars are often very bright, but there are very few pixels that have these values that contain a star. What the most of the image is made of is the background sky, the background of the sky, and the nebulas, depending on which size they are in the image. And so you can see here that the grid is the grid is in 10. There are 10 lines in the grid, and what is generally considered as a good rule of thumb, let's say, is to put the background at 1/10 of the brightness of the image. So like that should be not too bad. Actually, I find it a little bright, but then the more you go to the left, the brighter your image will be, and so the better you will see the nebula itself, and especially the small extensions of galaxies, for example, or nebulas also. So maybe you want to see better these parts of the nebulas and galaxies, so you really want a brighter image, but then you can offset that to the left by changing the level of the black value, let's say, like the second cursor of the previous tool that we used. So you can continue moving this to the left if you really want a bright nebula, and this to the right. But taking care not to go too far because it will just make everything black then. And find something that you like. If your image is not doesn't have as much signal as this one, you can zoom in using this box here and buttons, and then it will be easier to move the values, the cursors, and get something that looks better. So I think here it's not too bad. Maybe it's a little stretched, let's say. Maybe I don't want that much of a stretch, and I will just smooth it a little like that. Okay, so I like my image here. So now I can click apply, and when I click apply, the pixel values of the image will be replaced by the one we are seeing here in the preview. So now we have our linear image that has been modified to show the nebulas and faint objects as well as we would like to see them for like to show people or to show ourselves too how good our image was. Is this clear until now?
That's fantastic. That's very, very useful.
Yeah, thank you. Okay, I'll continue then. So now we have done most of the work. Our image is quite nice. There are a few things that we want to do before saving it. We may want to do. It's not mandatory again. In some cases, especially if you have not done the photometric color calibration, but you've done manual color calibration, you may end up with a green tint on your image. And because in general, only the blue and red are equalized, but you still have some green in the image, and in space there is rarely green in the background especially. So it's maybe something that you want to remove before considering your image being completely processed. So we have a tool for
Vincent, I have a question, sorry.
Yes.
When you do the photometric calibration,
Yes.
I thought it's only changing the colors of the stars. Is it changing that of the background as well?
Yes, it's so to better explain that, I will go back to the histogram transform. What happened was, or actually maybe I can show. Yeah, I will go back to the to a previous version where I had the green image like that. Yeah, so I can show you the histogram of the image and you will understand. So I'm too much zoomed in. Okay. So you can see here that we clearly have 3 different peaks for the 3 different channels. This means that the background itself is not gray or black. It's mostly green, a little red, and less blue. What the calibration does, either manual or the photometric one, is to realign these 3 peaks. So it will modify the values of the pixel of each of the color channels to make them match a little better the grayness of the background, and also the high values of the which correspond to the stars will be modified so that the star have the correct color, and what's in between, so the nebula and all the objects that are in the image, if they have a correct background and if the stars that are near them have the correct color, they will also have a correct color. So it's about realigning the background and stretching the different maximum values of the maximum values of the different channels so that they give a correct color.
Perfect. Yeah, thank you.
So now, is it, I think, can I go back to where I was before? Yes, it works. Haha. So I'll get back my nice image. And so now if you still have green in the image, so in general, it's not supposed to happen with the photometric color calibration, but sometimes it happens apparently, but it's not very visible. But it will happen if you do the manual color calibration. We have a remove green noise tool. It's not really noise, but it's called like that in the Photoshop plugin, I think. So that's why it's this name. And this will, so if I just click apply, maybe it would change the color of the image. Yeah, slightly. So there was still a bit of green left over. I'm not sure if it's real or not, but I mean, I'm not sure which one of the two was the photometrically correct one. Then you may look at the colors of the stars to verify that they still look correct. Yeah. If you have green stars, it's not good in general because it doesn't exist. So that should be, sorry, which one? Yeah, this one. That should be a good thing to do if you have green star or if you find your image is too green. So next step, so that was an easy one. Then you can change the color saturation because we have increased the brightness of the different objects and the different clouds, let's say, in the image a lot, but it has also brought up the color of these objects. And if you have ever looked in a telescope with your eye, you will notice that you don't see the colors like that. And maybe you want your image to be more like what you would see in a telescope. Maybe you want your image to be more like what you see in the APOD, the astronomy picture of the day. In that case, it's much, much more saturated in colors. Then you might want in these two cases to adjust the color saturation. So in the image processing menu again, we have this tool, color saturation here. It has two sliders. One is for the amount of color you want to add or remove. So if it's higher than 0, it will increase the colors, and lower than 0, it will decrease the colors, of course. And the second one, it's quite interesting. It's a threshold that will allow you to not change the colors of the background. In particular, if you want to increase the color of your nebula, if you don't use that, it will also increase the color of the noise that is still present in the background of your image. If you have some, in general, you will have some, and so you don't want that. So here we can adjust this factor. So I will increase the color so that you can see better what I mean. If I put that lower, you will see that the what we can call a cloud, let's say, is getting also oranger, more red. But if we increase this this cursor, only the brighter objects will change color saturation. So it's a way to prevent the background from getting too much colored, which is often a problem when you have stretched the histogram like we've done, because it will also increase the contrast of the noise of the background. If I zoom in the image here, sorry, if I zoom in, I can see that it's very blue in some parts, very red in some others. If I return to the original image, I didn't see the difference actually. Okay, so maybe the factor is too high. Yeah, here we can see that the red parts that are very faint are getting very red now, and maybe too much, because you see the noise is also getting a lot of color information that maybe it's not very good. Here we are just looking at the image on a very zoomed out view, but if you want to see the full image, like actually there is yeah, if you click here, you can see it a bit bigger. But yeah, if you look at it in full screen and zoom in the image, you may not want to have a lot of noise in the background. So that's a way to prevent it. Here, for the purpose of the exercise, I will just increase it a little. I'm not a big fan of very colored images, so I think like that it will be all right. Yeah, okay. I click on apply and I get again my pixel values have been modified, not just the rendering. Also, I'm in auto stretch mode, so it wasn't the best move. I should have done that. Oh yeah, that's why the color are strange. Yeah, sorry, I will do that again, but in linear. I switched to auto stretch to show you the histograms before, and I forgot to go back to linear. So that's I fell in the trap. And so I will again change the color saturation. The cursors are not at the same place where I put them, but it's the actual rendering will be like that. So it's important to stay in linear mode while doing that too. Yeah, so I think like that. It's very red, but it's okay for the exercise, let's say. And then the final thing to do before saving the image to web format, optionally, is to rotate the image if you like, and crop the image if you like. If you have a galaxy and your field of view doesn't have the galaxy in the center and you really want to recenter it, you might crop the image. So you just go on one of the three monochrome channels, you draw a selection with the mouse, and then you can right click on the image and click on crop. So I will not do it now because it will destroy the astrometric solution, but it will resize the image on the selection. You can also rotate it using this tool, geometry. In the geometry submenu, you have like the 90 degrees rotations, but you also have the free angle rotation here. So you can have your, I think it was 100 degrees. I'm not sure on which direction, if we want to try it. Oh yeah, so, well, it's not important. We can do that. So that may be the orientation of the two nebulas in the sky, for example. But then you have the aside a part of the image is black, as you can see. So it's not maybe the best thing to do. So let's go back. Okay. And so once you have rotated your image, cropped it as you like, now you can export it because we consider the processing is finished. And so after each step, you should have like the correct color. After the color calibration, you should have the correct brightness of the objects and the background and the nebulas and so on. After the histogram transformation, when you look at it in linear mode, it should already look as you want to produce the image. When you change the color saturation, it must look like what you want to export, of course. And then the export, so you can either use the menu or actually I'm not sure which one to do that. It's not the open menu. Or what we do in general is, oh yeah, it's the save as menu. It's the same as what I used before. What we do in general is right click on the image, the RGB image. And then you have a few options to export as PNG, for example, or JPEG, if you want to publish on the internet. but maybe you would like to reprocess your image in Photoshop, for example, which may have more powerful tools than Siril. But yeah, in that case, you may save it as TIFF. And if you want to use it in another astronomy software, you may save it as fits, just what I did before. So here we will export it as JPEG. So remember that what will be in this file is what the linear mode shows. And so if you're not in linear mode, the image will not look like that. Let's type a file name. So it will be like M8 and maybe with underscores M20 Basingstoke. No, missing the G. And maybe change the compression if you like, depending on where you want to publish it. And so now I have finished my processing, and if I go to my directory, which is the current working directory written at the top of the window, or actually you could have changed it in the export window, I get my image, and I should be able to open it. Yes. Oh, sorry, which one? Yeah, it's this one. And we have our image. Ta-da! Simple, no?
Yeah, yes, you make it look very easy.
Yeah, so that's a very good image that I had in input. It's not a very long exposure image, but it's a quite good quality with a lot of signal in the image. It's harder when you get lesser quality images, because of course when you will stretch the histogram, you will get a lot of noise that gets brightened by this operation. So you will be limited by the contrast that you can get on your object because of the noise that will be visible. So that was a simple case, let's say.
Vincent, is there an etiquette when you're processing these images? Because I've had a go at these test files using the tutorial steps that are online, and I took out quite a lot of, because I like the contrast of the nebula against the kind of darker sky, so I took out quite a lot of the kind of background stars to make the nebula stand out more. But I realised now, having gone through this, that actually it's not an accurate representation. So I wondered, is there an etiquette when you're doing this sort of stuff, or is it purely personal preference?
I believe it's purely personal preference.
Okay.
You should still be able to see the stars brighter than the nebulas or galaxies even. I think the biggest limit to how much you can brighten a deep sky object is how much noise will come out when you do that.
Yeah.
For me, that's the main limitation. Then you can do as much as let's say as good, as well as it suits you. I mean, you can do pretty much what you want with your image, but if you have the wrong colors, for example, it might not look very good in the end, except in some cases where you have like narrow band filters where you have to have wrong colors, but it's more an aesthetical rendering.
Aesthetics. Yeah.
Aesthetics. So it's it really depends on what you want to do. I don't think there is an etiquette, as you say.
Sure. Okay.
Yeah.
Thank you.
No problem.
Vincent, one question: are there any noise reduction tools in Siril?
I think it's being developed. I'm not sure it's already in the.
Because that's the place where I get confused, right? You have this Fourier Transforms, you've got loads of other little options there. I don't know what to do with it.
Yeah, no, the Fourier transform is it's generally used to remove a pattern that appears on the image. It's like if you have a grid because of a poor camera that is that you can see clearly. The Fourier transform can help you with that, but in most uses it's not very useful.
Okay.
The median filter is a good way to remove the noise, but it will also remove a lot of your signal, or it will decrease the resolution of your image. So it's not a very good idea either. So no, I don't see in the list the actual noise removing tool. It's in the list of things that we are about to develop. So it's not yet in this version. But I would say that the main way of removing the noise is stacking more images.
Yeah.
So if you have your session and you cannot do more, it's maybe you can tweak a little bit the parameters for the pre-processing, like the rejection settings or the star detection settings that are used for the registration, but in that case you need to pre-process manually.
Okay.
And you may also verify that your calibration files are good. If you have like a bad flat field image, it's in general the best way to get a bad image. Let's say. It can, if you have bad calibration files, it will ruin your image. So that's for sure. Making sure that they are good and that the pre-processed in the term of this tool, the pre-processing, which is the calibration of the image, basically, making sure that the calibrated lights images are looking good already. Is a good way to verify that your flats and darks are correct.
Okay.
But yeah, other than having more images to remove the noise, for now we don't have something that will do what you asked.
Okay. Perfect.
Long answer for
One other
short.
question, sorry, was
Yeah.
to do with the calibration, right? What you were talking about.
Yes.
I heard that one way to do this is to have flats, and then you have dark flats.
Yes.
But
So it's just terminology problem. Well, not problem, but thing. What is usually needed to calibrate the images is a dark and a flat, but I mean the master dark and the master flat. But the master flat itself must be calibrated with the offsets of the flat. And so if your flats have been taken with the shortest exposure, it's the calibration of the flat can be done with an actual offset. But if your flat required a few seconds of exposure, then it becomes something that is more a dark image that has the same exposure as the flats. And to differentiate the dark that is used to calibrate the lights, that is the same exposure of the lights, and the dark that is used to calibrate the flats, that is the same exposure of the flats, we use this term dark flat or flat dark, I don't even remember.
Yeah.
So it's just an additive signal calibration file. So it's either an offset or a dark. It's basically the same. It's just you make an exposure as long as the as long as the flat itself. And so that's only the calibration file for the flat.
And where would we do that in Siril? If I needed to calibrate the flats, and then I've got a flat, I've got a dark flat. Now I need to get the master flat, right?
Yes. So if you use the scripts, it's automatic. You actually need to put this dark flat in the biases.
Oh,
biases.
I see. Okay, so the biases become the dark flats, right?
Yeah,
okay, got it.
That's it. It's not used for calibration of the lights. It's just used for the flats. So
okay,
that's
perfect.
The problem is that we didn't change the name here of the directory because historically it was named like that. And so if we had changed it, everybody would have to update the way they use Siril and also every script that they use.
Yeah.
So that was complicated. So it's explained in the tutorial, but yeah, it's not easy to understand it at first. Biases here is the offsets or the darks for the flats only.
Okay, perfect. Thank you.
And if you do it manually, you just use your dark flat images here. Or actually you stack them first, and when you get the dark flat master, you put it here and pre-process your flats with that, and then you get your master flat that you can use on the light images.
Perfect. Yeah, understand. Thanks.
Vincent, I've got a question.
Is that?
Go ahead, Kirsty.
No, you carry on. I've already asked one. Go on.
Right. It's to do with the rotation of the image when you've finished the processing. You had 90-degree rotations, which are sort of automatic. And then you had a manual one where you could rotate it any amount. Is there one for making north up or north down automatic, or do you have to do that manually? If I want north upwards.
Yeah, that's a good idea actually. I don't think we have that automatically. You can still see in the console when you do plate solving, so either manually or for the color calibration, you get the rotation compared to the north. But then, as I've showed you before, I'm not sure which direction I should rotate the image. So I'm not sure if it's so geometry rotation. I'm not sure if I need to put 107.91 here or minus 107.91 here. So no, there is no automatic way to answer you, but it's something that we might think about indeed.
Okay.
But then the problem is that if you purposely put your camera sideways like that, then when you automatically rotate it, you have black areas on your image. So maybe it's not that good. Yeah.
Thank you.
I don't know why we have more black than the size of the image actually. Maybe it's a bug. Yeah. Is there another question? I still have time. Don't be afraid.
Going to ask Vincent. Thank you. You were talking before about doing manual processing versus using the. Oh, thank you. I've been delivered a gin and tonic. That's nice, isn't it? You were talking. Cheers, everyone.
Cheers.
You were talking before about using the manual processing, pre-processing versus the scripts that are already written. Is there? So when I've had a go at the tutorials before, I've just used the scripts because not clever enough yet to do it manually. But before I give myself a load of work to figure out how to do that manually, is there a huge amount of value in learning how to do the pre-processing manually, or is it just a bit of a nerdy thing that might be nice to do and actually is not going to deliver any different results?
So indeed, there is quite a gap between just putting the files in the directories, running a script, and doing all that manually. You really need to understand what I was talking about before with the different calibration files that have to be each of them manually stacked and so on. So it's easy to get lost in the process, even for someone experienced. But what can be done is do a part of the process using the scripts, even the entire process if you have time to let it run, because for big data sets it can be a bit long, but maybe you can just run the script. And then once you're getting to know Siril better, maybe you want to come back to some of the steps that are done in the script and redo them manually. So, for example, what sometimes happen in with the scripts, because it's automated processing and it may not work with all the image qualities, is that the registration doesn't find the stars in the image. In that case, you might want to load the intermediate sequence, because Siril only works with sequences, or actually it works with a single image loaded, like what we have shown, like what I've shown you today. But in general, it works with sequences of images, and you can load an entire sequence and display one of the image of the sequence, but then do some actions on the entire sequence. If Siril doesn't find the stars, for example, you can reload the sequence that was created by the script, and I will show you how to do that. It's quite simple. So all the images that were given in input to Siril are in these directories, and it created this directory process during the script execution, and it contains all the master files. It contains the preprocessed calibrated lights and flats and so on. So you can go in this directory. I will move this. And so change the directory using the home. Go in the process, and so now it shows process here. And then in this sequence tab, you can search sequences, and for example, load the one that was created by the preprocessing step, so the calibration, and it's called PP light. PP for preprocessing, and the light is the sequence that was originally preprocessed. And if I click on that, I will see the preprocessed, so the calibrated lights. And then if I want to understand, so here you can see, we can still see the satellite tracks that were removed by the process of stacking later. But here we still have the basically raw image calibrated and not yet aligned. Now, if Siril says registration didn't find any star, I go in the registration tab, and so it's not the correct one. It's the global star alignment that is used in general. Here I have the settings for the stars detection. Sorry. If I click on this button here, detect stars, it will bring me the list of stars that are found in the image. So it will take a bit of time because it's a very big image with a lot of stars. But then you have three values that you can change to modify how stars are detected. So if you have an image with a lot of noise and very faint stars, so that's a lot of stars that show up. Maybe you want to, if you have an image like that, so it will not say that it doesn't find stars, but if you want to speed up a bit the registration, for example, you can only detect stars that are above 3 times the standard deviation of the background of the sky, and also that are like 80% round. And if so I had 24,000 stars in the image. Now with the new settings, which should run faster, I have only 9,000 stars and a half. So it's still very big. But for images that are very bad, it will be useful to decrease the threshold, for example, and tweak a little bit these parameters to see if there is a way to make it detect stars. So that's one reason to go to manual. The other main reason, it's even more important in general, or it will, I mean, what I just showed you is like if you have an error during script processing, you will not be able to process your images anyway. So you have to get manual intervention. But even if it proceeds correctly, there is something that you might want to do to improve the quality of the resulting image, is the stacking step. And so I will load the registered sequence to show you what I mean. So in this sequence, all the images have been rotated and aligned with each other. So if I change the displayed image, it always looks the same because they are all aligned. And so the next step is stacking the image. But what can happen is that you may want to select only for stacking the best images, while the scripts stack all the images by default. And if you have, let's say, 300 images, the subs, maybe you want to keep only the 200 best, or maybe the 250 best, because maybe during the night, the seeing changed, like here, and at the beginning, the half, the FWHM, so it's the full half width. No, what's that already? FWHM.
Full width, half.
Yeah, full width, half width, half
I don't know what
magnitude. No, I don't remember. So it's basically the size of the stars in the image, or half of it at least. And so it was 2.8 at the beginning of the session, and it reached 3.7, which is quite, it's significantly higher. So maybe you want to exclude these two images, for example, from the stacking, and you want to stay even below 3.4 arc seconds. I'm not sure if it's arc seconds or pixels here, but it should be written somewhere, but it's not. Okay. Anyway, so maybe I want to stay below 3.4, I said. So you can see on the right here, the 3.42. Now, if I keep only 70% of the input images, I can go below this threshold and stack only the best images in terms of star sharpness. Here it's 70%. It means that I'm losing 30%, but it's because it's a very small sequence. It's only 15 images, or yeah, 15 images. So that's why it's so high, the amount of loss in percent. But and the same can be done with the roundness of the stars. If you keep like 70% of the best images, you will get stars that are round to 88%. So 100% means completely round, and like 50% means that they are elongated twice on one of the axes. So that's for me the main reason to do a manual operation. And you don't really need to learn about all the calibration and so on to do that. You may just run, and that's what I did here actually. I just ran the script from the basic OSC preprocessing entry, or the basic script that is given with Siril, I mean. And I reopened the intermediate files that the script produced. And now I can make a new version of the stacked image. So it means that after stacking, I will have to go back to the whole processing that we've done tonight. But maybe you should have, if I really wanted to do that, I would have done it before, of course. Or maybe you want to process the two images and see the difference on the final image too. And that's a way of doing, because having sharper images will give you, of course, sharper stars and more details in the galaxies or nebulas, possibly. But what will happen is with less images, you will also get more noise. So
Sure.
it's a trade-off, and you have to try different values and see which makes the best results. And until you have actually stretched the histogram and produced an image, maybe you won't see much of a difference, or maybe you won't see how badly the new noise that you've not removed will make your image okay or not okay. Let's see.
Okay, that's really helpful. Thank you. So I guess you would do it after stacking, and then you'd tinker with the stacked image, a stacked file, rather than going in and tinkering with the individual files. You would just exclude the one. Yeah. Okay, that's helpful.
I think
Thank
so.
you.
Yeah. And also there are the rejections. Yeah, I didn't talk about that, but how Siril works for the stacking is that it's an average that is done between the pixels of the different images, but also it's not it excludes from the stack actually of so imagine you stack the images one on top of each other. For each pixel, what you get is a stack of values, and these values are normally averaged, and we use the mean as the final image value for this pixel.
Okay.
But in the stack, some of the pixel values may be deviant or may not correspond to what is supposed to be at this place in the sky. Maybe because a plane passed in the image, or a satellite, or maybe because of the noise of the camera. Maybe you have a bright pixel or a dead pixel on the camera that appeared at this location on one image and not on the others, so it's easy to filter it out. And so these are the tweaking parameters that will exclude or not the deviant values. And so I can do the stacking again. I will show you. It's very fast on this computer, and it's done. Okay, so we have the statistics of the rejection, and it's a very small number of rejected pixels, and maybe we want to include a bit more. No, sorry, maybe we want to exclude a bit more pixels, because rejecting not too many means that we keep maybe too much noise in the computation. Well, so here I have only 15 images, so it's not very what's the word for that? Yeah, I don't remember how to say that, but it's not representing very well the reality. But maybe you will have hundreds of images, and in that case you will probably get higher values, especially if you have a noisy camera or too short exposures too. Because here I think these are like 2 minutes exposures, so it's quite that's why we have a lot of signal. Anyway, so you can also change these parameters and have a different outcome in the stacking, and you can try it again and again until you are satisfied with either the statistics. So here I have much more rejected pixels, for example, so it means that I may have less noise in the resulting image, but I may also have less signal, and I mean I may have not as round stars, because their shape depends on the different images that were stacked, and if some were too noisy on the sides of the stars, maybe they were excluded, and so on. So you really have to zoom in.
I guess it's trial and error, is it?
Exactly. It's exactly that. But you have to zoom in the images in general to see the difference. Maybe if I do that, I will see the difference.
Vincent,
yes.
Is it possible to load all the light images up so that you could go through the sequence of them and maybe reject them, if they've got an airplane that's gone right through the middle of your nebula?
You can do that. So it's in the, so let me zoom out, and in the sequence, tab, you have the frame list. What? Oh yeah, sorry. I was with. I have to reload the sequence because I'm displaying the stacking result. So if you reopen your images, and for example this one has a plane track or a satellite track, and you want to exclude it, it can be done like that. So this is the loaded image, the one that is selected, and you have a selection checkbox here. You can unselect it like that, and then in stacking you can just use the selected images filter. That's how you can do that. But as you have seen, this image was included in the stack, and yet in the result we don't see the plane trail or satellite trail. So it's not really necessary, because the stacking will see those pixels on this image as too much different from the same pixels of the other images, and so it will not be taken, it will not be used during the stacking process, just for this.
So will it just
will
it just exclude those pixels, or will it exclude that whole image?
Yes, just the pixels.
Oh, okay.
So that's what these two parameters do.
Yeah. So that does it for you, George.
Yeah. So you don't have to exclude them manually, except if you have like a flash of light in the entire image or something. You may want to do that.
or a cat that jumped on the telescope. Never happened.
Yes.
But you will occasionally get maybe a little bump on the mount.
Yes.
And all the stars move.
But in that case, you can filter by FWHM or roundness too. But that's not indeed something that the script does manually, automatically, sorry. But still, if you have all the images with very round stars like these ones, and one image have stars very elongated, then the pixels of the stars that are going outside the normal star size will be considered as deviant and will not also be taken for the stacking. So it may not have a very big impact, but it may have a little impact still. And so it's better in that case to filter by, it's an automatic filter on the image quality. So you don't have to filter them out, to unselect them from the sequence like I've done before.
I might get a bit nervous because your nebula will also be like that, and that might cause problems. Okay, probably okay with stars.
Yes, for the nebula it's much more a problem than for stars, actually. You're right. We have another trail here. Actually, there are many trails in this image. So we have 3 satellites in 2 minutes. Not bad. It's a very wide field too. So.
It's probably Starlink for you.
Yeah. Actually, it's a quite old image now. I'm not sure, but.
Oh right.
Oh, it's like 2 years old.
No Starlink at that time.
Well, unfortunately, we live near Heathrow Airport.
Yes. Yeah, I live near the Nice airport. Yeah, I didn't tell you, I'm on the French Riviera, so I have a lot of nice sky, except for the airplanes and the city lights. But I have the mountains.
You're lucky.
And less jet stream.
Yeah, probably too.
Don't gloat.
And the Mistrals?
The Mistral, the wind?
Yeah.
Yeah, I live on the side of French Riviera that doesn't have as much Mistral than in Marseille, for example. Near Nice, it's quite calm.
So he lives in the perfect environment for sky gazing.
Yes, it is. And actually, we have the best sky in France nearby, with the highest road in Europe that goes up to 2,800 meters. And yeah, so we can put some telescopes there, and it's quite a good sky.
How lovely.
Yeah.
Okay, next boot camp is in Nice for us.
We're all round to Vincent's.
Yes, I invite you all.
Vincent, this is very, very interesting, and thank you very, very much for doing this. I have a feeling, if you're open to it, that maybe the end of this season, our winter season, we might invite you back, because we may have greater knowledge of Siril, and we may need to pick your brains in a slightly different way.
Yeah, with pleasure, no problem.
Yeah.
And by then, I'm sure Siril would have advanced another few versions, and it'll have a lot more features as well.
Yes, it's evolving quite rapidly. So
exactly, because I've seen it from version 0.6, and now we are already in what, 0.10, are we?
Yes.
Yeah.
Yeah, and we have new things in preparation that are not yet released. So it's yeah, we have a few active developers, so it's quite progressing well.
Yeah, good luck with that one.
Thank you very much.
Excellent, excellent. Has anyone else?
It was super useful, Vincent.
Sorry, I didn't hear you.
I just wanted to say a big thank you to Vincent. It was a very good presentation, and hopefully that our First Light group will come on leaps and bounds because of all of this information. So yeah, thank you from me.
Yeah, thank you, Bob.
Yes, thank you very, very much indeed.